Okay, so in this last unit, we're going to start looking at things that aren't linear, which means that they have exponents involved on the variables that aren't just one, right? You remember that linear equations look like b plus mx, where the exponent on the variables is just one, right? We don't write it, and that keeps things simple. But we're going to look at things that are a little bit more complicated, so they're going to involve exponents. This is a place where a lot of the misconceptions come and then start to spiral throughout a student's algebra to calculus trajectory. And even if you get off before calculus, this can kind of plague you between now and pre-calculus if you don't do it the way that will always work. If you just remember the shortcuts, I'm going to tell you right now, they don't work. It fails about 80% of students that remember them, and that's why 70% of students test into remedial math when they should be probably at higher levels because of these shortcuts that get in our way. And I'm going to tell you that I've got a way that will work every single time, and it's using one thing that you already know always works. And that is the simple rule, that the general rule of that you know that 2 times 3 times 4 is the same as 4 times 3 times 2, right? What do we call this? We call this the commutative property. Okay, so the commutative property tells us that with multiplication, you can switch the order of factors, and it doesn't affect the outcome. Okay, so that is the one thing that we'll use that we don't talk about explicitly often, but we use it all the time, right? We rely on this. This happens with addition as well. It does not apply to division and subtraction, but it applies to multiplication. Okay, so we have the commutative property. You know that this always works. This is always, right, 6 times 4 is 24. 12 times 2 is 24. This will always work no matter how you slice it. Okay. So there's that, and then there's also the definition of exponents. Let me scoot this down here. Which is that, 3 to the 4th power is just 3 times 3 times 3 times 3. It's multiplying itself 4 times, right? And likewise that, 2 to the 3rd power is just 2 times 2 times 2. You multiply itself 3 times. Okay, this is different than 4 times 3, right? 3 times 4, that's 3 plus 3 plus 3 plus 3, right? So that's completely different. That's not what we're talking about here. We are talking about repeated multiplication. Okay, so two things. We have repeated multiplication, and we know that the order of multiplication does not matter. Now, how are we going to use that to simplify things like this? This can often bring on anxiety for folks because we see a mix of letters, numbers, tiny numbers in the superscript. What do these really mean? This means repeated multiplication. Okay, that's thing number one. Exponents mean repeated multiplication. Okay, so that is thing one. Thing two is that we can rewrite how factors are ordered. So I'll show you what I mean. We want to kind of group factors by type. So we'll have coefficients and variables. If we have more than one variables, we'll have variable type 1, variables type 2, etc. So I'll show you what I mean. Let's take this. I'm going to write it a little bit bigger. 4x squared times 5x to the 6. Remember how terms in algebra have a real number part and a literal part. Right? They have the variable piece and the coefficient. Right? Coefficient's yellow, the variable part is blue. So what we can do first is start off by rewriting it, since this is all multiplication in here. Right? Between each of these are all kind of glued together with multiplication. I don't need a times there. So what we can do is rearrange and say this is the same as 3 times 4 times 5 times x squared times x to the 6th. So notice what happened. I rearranged so that all my real number coefficients came out in front. So I got that kind of type grouped up. And then I've got my variable parts over on this side. Why is this okay? Because of this. 2 times 3 times 4 is the same as 4 times 3 times 2. So I can write this any way I want. These parentheses just mean multiplication. Okay, so I can drop those since it's just multiplication and there's no addition or subtraction involved. I don't need to distribute anything. So I can break those down and rewrite in this order. And now, carrying out this multiplication is pretty easy. 3 times 4 times 5 in your calculator or just in your head, that's 60. And then what do we do with this variable part? Well, we're trying to simplify, right? That's really the goal, is to come up with a condensed expression. So what I want you to think about is, what does this really mean? Well, x to the first really just means times x. X squared is really, I have two factors of x times x. X to the 6th means what? It means I have 6 x's in a row being multiplied by each other. 6. So this is really what I want you to do, is to write these out. You might say, Mally, this is tedious. It's not, because you're showing your brain what's actually going on, and over time you'll speed up, I promise you. Okay? This is 100% the way you should be doing this, and any other shortcut will fail you if you don't understand what's happening. So show your brain for a while why this makes sense. So now what do we have? We have 60 times a bunch of x's. These are being multiplied by each other. How do we rewrite x's that are being multiplied by each other a certain number of times? We use exponents. This is really 60 times x. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 60 times x to the 9th. So that's the most condensed form of this expression that we started with. So what did we do? We realized that exponents mean repeated multiplication, and that we can rewrite factors in a different order. So we had the type of coefficients out front, and then variables to the side. And then we break them apart and then count. How many x's do we have? So let's do another example right now. While we're on the trail here. So simplify. Negative 2x times 6x to the 5th times negative 4x squared y squared times 3y to the 5th, to the 6th. Okay. So I'm jumping for medium to more difficult types of problems here, just so you can see all different parts of the process. So there's a lot going on, but the same exact thing is really happening. Identify your coefficients. You can rewrite this. Negative 2, 6, negative 4. Why are you using brackets, Mally, and you weren't before? Well, I have negative coefficients here, so this is going to help me remember that those aren't subtraction. They're really negative factors. And then I've got variables, but I don't just have x terms, right? Be aware of the whole field here. I've got x terms, and I also have y terms. So I'm going to keep those grouped up by type. So I'll have x times x to the fifth times x squared. And then I'll do times y squared times y to the sixth. And you see how everything's accounted for here. Now you don't have to use multiple colors, but it can help to use a pen and a pencil to kind of differentiate what's going on. But now we can move forward with simplification. So the coefficient part, you can just do this in your calculator again. So this will be what? Negative 12 times negative 12, which is positive 144. And then my x pieces, and again, pause this at any point to verify and check. My x pieces I'm going to write out. So I have x times x, 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 times x times x. And then my y variables, I had y times y, times y, times y, times y, times y. I had 6 of those. So verify that those are all good to go. And then I can, so I broke them apart, and then I can collapse them by knowing that exponents mean repeated multiplication. So I can simplify, because I have 1, 2, 3, 4, 5, 6, 7, 8 x terms. And I have 1, 2, 3, 4, 5, 6, 7, 8 y terms. Or factors, not terms. So we have 8x factors and 8y factors. And so what we're left with at the end of the day is 144 x to the 8th, y to the 8th. So, man, English is tough. So this whole thing simplifies down to this, because we can rewrite using the order of multiplication, the commutative property, and then also the fact that exponents mean repeated multiplication. Okay, so just those two facts allow us to condense these things, and this is a key skill. And if you do it this way every time, you will not make a mistake, I promise. Or if you do, it will be so easy to find, you'll know what happened. If you're just using shortcuts, you will not know what happened, and that is the problem, right? Math is not magic. It's based on how our brains work, and it should always make sense. So I want to move into a problem where we involve division. So let's say we have something like this. X to the fifth over x to the third. And I'd say, simplify this expression. So this is different because we have division, right? But the first truth still holds, which is that exponents mean what? Repeated multiplication. So I can rewrite these as x times x times x times x times x all over x times x times x, right? Break it apart to see what's happening. The second thing you need to know that's true for division problems is that any number over itself is what? 1. And so this is how we effectively cancel common factors to simplify, because we don't need to write extra ones everywhere. So what's really happening is that we can rewrite this as a series of factors like this, times x over 1 times x over 1. And then this is just 1 times 1 times 1 times x over 1 times x over 1. So what's x over 1 times x over 1? It's x squared over 1. And remember that anything over 1 is just itself. So at the end of the day, really this x to the fifth over x to the third is the same as just x times itself twice. Because it's really, sure, we're multiplying x by itself on the top 5 times, but on the bottom, we're also multiplying it by itself 3 times. So 3 of those times kind of get balanced out between the ratio of the top and the bottom. Algebraically, we see that means that we get 3 factors of 1 here. And that's why you see people do this cancel maneuver and then show what we're left with. This is fine to do as long as you realize that this is really what's happening. We have a number over itself, and that always reduces to 1. So what happens if we beef it up a little bit? Let's say I've got 3x to the 4th y squared over 6x to the 8th y. So again, we're going to use this idea that exponents mean repeated multiplication. So I can break it apart and then put it back together again. So let's see what's happening. So I get 3 times x times y all over 6 times x, 4 more, times y. And then what do we get to do? Well, we're going to get to cancel some common factors, that's for sure. You might also notice that 6 can be broken into factors of 2 times 3. If you notice there's a common factor, go ahead and do that because we're trying to reduce this thing as much as possible. So this 6 became this 2 times 3. What that allows us to do is then cancel a common factor of 3. And then we cancel 1, 2, 3, 4 sets of x, right? It's a 1-to-1 canceling because it's 1 over 1 for all of these. And everything else remains untouched. Well, what do we have over here? Hold on. We have a y that cancels, right? So that also goes away. So don't go too fast. And don't talk at the same time you're doing math. So we've got y on the top, we've got 4 x's on the bottom, we've got a 2 on the bottom. And so what do we have left over? We have y over 2x. How many do we have? 1, 2, 3, 4. And that's as simple as that one gets. Okay, so what made this one a little bit different? Well, we had this coefficient to contend with, so just remember that you can break numbers into their factors when you're simplifying. And we do the same with variables. Break it apart, and then cancel what you can, and whatever you're left over with is your simplified and reduced fraction. Now, you might do this in waves, you might not be able to do it in one shot, and that's okay. I do want to highlight one thing that comes up a lot, especially with the fractions. And it's based on not remembering this part correctly. Remember, you're left with 1, not 0 when things cancel with multiplication, right? So if we had something like this, x to the 6th, y to the 4th, all over x to the 3rd, y to the 3rd. Actually, let's do this the other way around. If I have x to the 3rd, y to the 3rd, all over x to the 6th, y to the 4th. Again, what do? We break these things apart. I recommend doing it exactly like you're seeing me do this. Why? Because it makes sense and it's based on the first principles of what we know. So I'd go through and break it apart to see, oh, I do have some common factors. I trade 1 for 1, top and bottom. The y's cancel. 3 of those for 3 of these. What am I left with? On the top, there's nothing here. So students will get confused and say, oh, well, this must be 0, or it must be x, or our brain just kind of inserts something if we're unsure. If everything cancels, what are we really left with? We're left with 1. So on the top becomes 1 over, and then whatever's left below. So we have 3 x's down here. So this is really all 1 over x cubed. Okay. So if you cancel everything from the top or the bottom, and this also happened in our first example, right? Everything canceled from the bottom, so you're really left with 1. So you're not left with 0. So we've covered how you deal with multiplying terms together that have positive exponents, dividing terms that have positive exponents. We're going to work into some different variations of these problems where we actually can generate negative exponents. You've played with them already actually in this video without really knowing it. And then getting into fractional exponents. Yes, it is a thing. They kind of arise just because of the way that algebra works. It just works out that we have these things called fractional exponents, one of which you're already familiar with, so it won't be that strange. But just to kind of gear you up for where we're headed with that. And so the idea here is that we learn how to play with these Legos, learn how these things work together, so then we can go in and solve equations and solve interesting problems with them using functions, graphs, tables, etc. Okay, so this is the direction we're heading with this course, so please take your time with the practice. If you feel like this is above you, or below you rather, feel like it's above you, that, also reach out for help. But if you feel like it's below you, give it an honest shot and don't rush through it, and take my word for it. Okay, there's a reason that we're here and we're taking the time in this course to relearn or learn for the first time these ideas in the right way, so that we don't pay the price later of having this big fundamental gap of not seeing how things play out. Okay, so this is how these structures, these numbers really play together, and it's based on what you already know. Okay, so I'm going to leave it there, and I hope to see some good questions in the class discussion. This can be pretty fun with the way things collapse together or produce weird results. So again, I'm looking forward to those questions, and we will see you there. Have fun.